So in this lesson, we want to look at solving absolute value equations. In example 1 here, we need to solve this equation, the mod of x equals 5. Now, when it comes to solving absolute value equations, there are 3 methods that we can use. You can choose the one that you prefer. For this example, though, we want to look at all 3 methods in order for you to gain more insight into absolute values. So let's look at method 1. So when we use method 1, we can use some theory that we did in lesson 1, where we looked at the definition of an absolute value. Now, remember the absolute value of x equals a, where a is a positive constant, implies that x equals plus or minus a. So simply applying this definition for method 1, we have the mod of x equals 5, and using this definition then, x will equal plus or minus 5. Let's look at method 2. So here we simply square both sides of the equation. So then the mod of x all squared equals 5 squared. And now the mod will drop or fall away. So we end up with x squared equals 5 squared, which is 25. And in solving for x is equal to plus or minus 5. Let's look at method 3. So method 3, or for method 3, we can look at this equation graphically, the mod of x equals 5. What does it mean graphically? It means we must find the points of intersection, or the x-coordinates of the points of intersection of the graph y equals the mod of x with the graph y equals 5. In other words, we need to find the x-coordinate at these points. Now, we know that the 2 arms of the absolute value graph will be y equals x and y equals negative x. So to find the x-coordinate here at this point of intersection, we merely make this arm of the absolute value graph equal to the line y equals 5. In other words, we merely let x equals 5. Then to find the x-coordinate at this point of intersection, so this x here, we make this arm of the absolute value graph equal to y equals 5. In other words, we let negative x, so this arm, equal 5. And we see here that x is equal to negative 5. Let's look at example 2. We have to solve this equation. So let's look at method 1. So for method 1, we can use a definition that we looked at in lesson 1. So the mod of 2x plus 3 equals 4 means that 2x plus 3 equals 4, or 2x plus 3 equals negative 4. And we solve for x here. So x is equal to a half for this equation. And here, solving for x, we see that x is negative 7 over 2. Let's look at method 2. So for method 2, we can square both sides of the equation. And of course, when we square the mod, it falls away. So we end up with 2x plus 3 all squared equals 4 squared, which is 16. And now we can solve for x. And here we end up with x equals negative 3 plus 4 divided by 2, which is a half. Or x equals negative 3 minus 4 divided by 2, which is negative 7 over 2. Then for method 3, we can solve this equation graphically. So we can draw a rough sketch. So firstly, of the absolute value graph. Now, we know that this arm here is y equals 2x plus 3. So the right-hand arm, and the left-hand arm is y equals minus 2x minus 3. Now, in solving this equation graphically, we're looking for the point or the x-coordinate of the points of intersection of the absolute value graph with the graph y equals 4. So we're basically looking for the x value here at this point of intersection, as well as the x value here. And we can find it by making each arm of the absolute value graph equal to the line y equals 4. So we can start with the right-hand arm here. So 2x plus 3 must equal 4 for the right-hand arm, this point of intersection here. And then also for the left-hand arm here, minus 2x minus 3 must equal 4. And now we simply solve for x. So x is equal to 1 over 2, and here x equals negative 7 over 2. Let's look at example 3 here. We have to solve this equation. Solving this equation is a little bit more complex than the equations we solved in examples 1 and 2. In examples 1 and 2, we had a positive number on the right-hand side. However, in this case, we have a linear expression on the right-hand side. Let's look at method 1. So this is when we use the definition of an absolute value. Now, we know that what's inside the absolute value can be negative, 0, or positive. However, the answer, in other words, what's on the right-hand side, can only be 0 or positive. So that already tells us that 3x minus 4 must be greater than or equal to 0. In other words, x must be greater than or equal to 4 over 3. Now, method 1 consists of two cases. So let's look at case 1. So case 1 is when what's inside the absolute value is 0 or positive. In other words, when x minus 2 is greater than or equal to 0. And that means when x is greater than or equal to 2. So we're taking what's inside the absolute value here as positive. So we need to solve this equation. The positive then of x minus 2 must equal 3x minus 4. We can solve this equation. And we see that x comes to positive 1. However, here we have the condition that x must be greater than or equal to 2. And 1 is less than 2. So this answer will be invalid. Let's look at case 2. This is when we take what's inside the absolute value here as negative. So when x minus 2 is less than 0. In other words, when x is less than 2. So we take what's inside the absolute value as negative. So we take the negative of x minus 2. And this must equal the right-hand side. In other words, it must equal 3x minus 4. So we can solve this equation. And we see here that x equals 3 over 2. So we check our answer against the condition that x must be less than 2. And 3 over 2 or 1.5 is less than 2. So this answer is valid and x equals 3 over 2 only. Let's look at method 2. So method 2 is when we square both sides of the equation. When we square the mod on the left-hand side, it falls away. So we have x minus 2 all squared equals 3x minus 4 all squared. Now, we have a choice here. We could square out both sides of the equation and collect all our terms on the left-hand side and then solve the equation as a quadratic. Alternatively, we can get rid of the square on the left-hand side by taking the square root on the right-hand side. And of course, when we take the square root of a square, it falls away. So x minus 2 will equal plus or minus 3x minus 4. We can solve this equation. We have two sets of equations. So x minus 2 will equal 3x minus 4, or x minus 2 will equal negative 3x plus 4. We can solve this equation here. So we get x equals 1. And solving this equation, we get x equals 3 over 2. Now, what's very important is when we square an equation like this, when we square both sides, we need to check our answers. So let's check our answers. So we're going to check x equals 1. And the way we're going to check this is by plugging 1 into the original equation to see whether it satisfies the equation. So then the left-hand side is the mod of x minus 2, so 1 minus 2, which is the mod of negative 1, which of course is 1. Then the right-hand side of the equation is 3x minus 4. So we plug in 1 for x. And we get negative 1. So we see that the left-hand side isn't equal to the right-hand side. And that means that x is not equal to 1. Now we can check 3 over 2. So check x equals 3 over 2. We're going to substitute it into the left-hand side first, which is the mod of x minus 2, so the mod of 3 over 2 minus 2. And of course, this is the mod of negative a half, which we know is positive a half. Let's check the right-hand side. So the right-hand side is 3x minus 4. So plugging in 3 over 2 for x. Here we can do this on a calculator, of course. So 9 over 2, which is 4.5 minus 4, does give us a half. And it means that x equals 3 over 2 is valid. So therefore, x equals 3 over 2 only. Let's look at method 3. So here we're going to solve this equation graphically, which means that we must draw a rough graph. So we can start with the absolute value graph. Y equals the mod of x minus 2. So the critical value, of course, will be 2. So this is the critical value. The y-intercept is when y is equal to 2. So just a rough sketch. So we've drawn the left-hand side here, which is this absolute value graph. Now we can draw the right-hand side, and we know that's a straight line. So the y-intercept is negative 4. The x-intercept will be 1.33, so about here. So we just connect these points. Now, from the graph, we can see that there's only one point of intersection. So the point of intersection is where the straight line graph intersects the left-hand arm of the absolute value graph. And we know the left-hand arm has the equation y equals the negative of x minus 2. So to get the x coordinate here of this point of intersection, we make the negative of x minus 2 equal to the straight line graph. So 3x minus 4. And we can solve for x here. And we see that x equals 3 over 2. Let's look at example 4. We have to solve this equation. So here we have a mod on both sides of the equation. I would suggest that if you have a mod on both sides, just to square each side, to square both sides. I think that will be the quickest way of solving an equation like this. So we square the left-hand side as well as the right-hand side. So, of course, when we square mod, it falls away. So we end up with 3x minus 2 all squared equals 2x plus 7 all squared. So once again, we could square out both sides and collect all our terms on the left-hand side and then solve the resulting quadratic. Alternatively, we can take the square root on the right-hand side. So we get rid of the square on the left-hand side by taking the square root on the right-hand side. And of course, when we take a square root of a square, the square falls away. So we end up with two equations that we need to solve. So 3x minus 2 equals the positive of 2x plus 7, or 3x minus 2 equals the negative of 2x plus 7. In other words, equals negative 2x minus 7. We can solve for x here. X equals 9. Over here, we get 5x equals negative 5 and x equals negative 1. Now we need to check our answers. So let's first check x equals 9. We're going to substitute 9 in for x into the original equation. So on the left-hand side of the original equation, we have the mod of 3x minus 2. So the mod of 3 times 9 minus 2. And this equals 25. On the right-hand side, we have the mod of 2x plus 7. So 2 times 9 plus 7. And this also gives us 25. So we know that x equals 9 is a valid answer. Let's check x equals -1. So on the left-hand side, we have the mod of 3 times -1 minus 2. And of course, this is the mod of -5, which is equal to 5. And then on the right-hand side, we have the mod of 2 times -1 plus 7, which also gives us 5. And that means that both answers here are valid.